Hey guys, welcome to my channel. Today we're gonna do one more USACO video. Um, Here, let me summarize the problem statement. So we got 5 cows, okay, and they're gonna perform a dance show, and we have a stage. So at any time there could be only K members on the stage, okay, and we have a time limit for the whole performance, okay. So the cows come up in this order, and the only limit, as I said, was the time. So they take this amount of time, each individual cow. So what we have to do is we have to find out the minimum value of the k, such that the dance performance can be done in this time. So let's do the sample input real quick, just for understanding. So the answer is 4 here. Let me just do 3 as well to demonstrate. So we got 4, 7, 8. Then we got one more, a 6, and it would make sense. This would be the thing that would be over first. So you would put 6 here, but 4 plus 6 is 10, and it exceeds the time limit. So 3 doesn't work, obviously. Now, if we add one more here, we can put the 6 here. And once the 4 gets over, it will be 8, and it can equal 8 because it said that's the max limit. So our answer would be 4. So how we can solve this is there are two parts to this question. One is so we'll have a checker method. What it does is it checks if a particular size or particular k will work. Okay. And the other thing is binary searching. Binary searching just ensures that we'll solve this thing in log n at most log n, which is necessary because we got a lot of things to try. I think I forgot. So we're gonna use a tree map. I forgot how much time tree map takes to get things in sorted order. It's probably linear. So I think our algorithm is n log n, but I'm not like super sure about that. Okay, so we're gonna discuss what a tree map does real quick. Okay, and we could actually use a tree set, but I'm using tree map, and I'll let you know why in just a second. So let's say let's use this example actually. So we can use tree set because basically it doesn't allow duplicates. So let's say if there are two 8s, it will only take one 8, and that's kind of messed up because like your k is decreasing, and that's not good. In tree map, what I'm gonna do is basically for each value I'll have a count. So if there are two 8s, I'll just increment the count of 8 in its value, therefore preserving the overall information, I suppose. So in a tree map, we're just gonna keep these things in order, right? So let's say initially all of them are zeros. We'll have 4 zeros, okay, like that. And when we put the 4, it will be 1 4 and 3 zeros. It looks kind of like this in the tree map if you want a representation of that. And we basically just keep filling 4 7 8 6, or wait, it's more like 4 6 7 8 because it keeps it in the order, and each of them have 1. I'm not going to write, that's just a waste of time. But next we'll have a 4. So always we add the next value, either it's always going to be added to the minimum value. So we're going to add it to here 8, and we are always going to check if the maximum value. So if this tree map will obviously re-update its things after we add a new element. So the maximum value is not greater than 8, so therefore that's an answer. And that's how it works. And the binary search ensures that we'll always get the right answer, even if it's like higher, lower, whatever. It ensures that we'll get the right answer. So let's take a look at the code. uh, that's this. Okay, so we're gonna have some static ins, and this just helps with not necessarily always putting in as a parameter, calling it as an argument. We can just call it as a global variable, and we take input here. We store all our cows dance times in dance times right here, and our max t is max time. We can have the performance going on, and low end, this part is the binary search, and the low, the high, the mid, and we're just going to outdog println high. And why I'm doing that is because we always update the mid, and let's say like 4 works but 3 doesn't. So then the mid is updated. So we obviously can't use mid. But every time a mid works, the high is set equals to the mid. Therefore, we always return the high. Um, so that's that. And let's just take a look at the works method, which is basically the checker method I was talking about. So we initialize a tree map that's an integer, and as I said, it's because we don't want duplicates. I mean, not we, but the tree set won't accept duplicates, and that's like a whole mess. So we're gonna, every time we call this, we're gonna go through the whole array, and we're gonna keep the first key, and if its size is greater than 1, we're just going to decrement the size. Otherwise, we'll just remove the key itself. And similarly here, we'll put the key plus whatever the dance time is at that particular index, and if it's already there, we'll just increment the value, or we'll add a new key. And then if the last key, because we always worry about the max. I mean, if the max is greater, then it's obviously false, right? The max in the tree map is greater than the max t, will return false, and we'll keep doing this until the end of the array. Only if none of the things return false, then we'll obviously return true, which makes sense. So TreeMap is a really useful tool, as I said, and you have to be careful between tree set and TreeMap. You have to be like 100% sure that there won't be any duplicates. Otherwise, this is how you implement a tree map, which is kind of like a tree set, but just that it allows duplicates if you think about it. Yeah, I think I covered everything, and it works very well with the runtime and everything. It takes a bit of implementation, but yeah, that's it for now. Thank you for watching. See you later.